Hi friends, I hope that you all are having a good one. The main aim of this video is to describe the perspective in which this blog post is written. To start with, a brief description about AWS aka Amazon Web Services. AWS provides a web hosting platform in the cloud. It means that it provides infrastructure as a service wherein tons of virtual servers or Amazon EC2 instances, as they name it, are created from physical servers and they are available online for public access. So for a website like Netflix, which is completely hosted on Amazon Cloud, the traffic management within the intranet or the data center is something that requires a great deal of attention. Why? Because there are millions of Netflix users alone in North America. So the entire pressure is put on the Amazon Cloud to deliver each video to each subscriber very smoothly. The focus here is effective traffic engineering in a data center environment or an intranet. We deal with layer 3 switches that are essentially more advanced than traditional routers, yet they work on the same protocols as that of routers. The key is if we somehow know the right utilization percentage of each router link, that is the red ones as depicted over here, we can form a traffic matrix and reroute the traffic to a less congested path, all through certain level of programming. That's the basic idea. Now, speaking of the boundaries for each network component, the virtual servers or EC2 instances are connected to a layer 3 switch within the data center, and these switches are connected to routers in the outside world. Chances are that there will be several intermediate routers pointing to the same destination user's router. In this case, there are 3 routers in green pointing to the same user router in blue. Always remember that a movie of the Netflix application is seated on the virtual server. Our objective is to identify the link state for each router and correlate with the corresponding switch and then decide the best path to route the movie packets to the user. This is done by SDN controller, which keeps on gathering all the crucial information and then decides upon a router configuration or the network topology. Thus, we can say that the control plane is decoupled from the data plane. One more interesting thing to notice here is that the data center resources are in our control. We simply cannot do much about increasing the routers in an ISP network. But if you are a data center admin, you can balance the load by adding more virtual servers and reducing the layer 3 switch load by deciding the best possible route given the same amount of routers in the outside world. You can keep adding the servers virtually and reduce the load from the switch whenever you feel like, and you can also reduce it as long as you know how to do it programmatically. So this phenomena is called scalability. That is, you decide what number of servers and switches are needed for effective network throughput and then change that number dynamically, all in real time. But for routers, it is the ISP, the Internet Service Providers, that decide the number of intermediate routers to be made available to the public. So, to sum up, the emerging SDN controller connects the applications seated on the servers with the data plane, and in that process, it continuously will keep on checking the traffic matrix that would help to reorganize the available paths, and it would take actions like switch migration, addition or removal of any server or that of a subcontroller module accordingly. Thank you.